All right, guys. So question number 33 says the force of magnitude 45 Newton acts at an angle 30 degrees on a body of mass 10 kilograms, initially at rest on a smooth horizontal plane. Find the distance covered in 15 seconds to the nearest meter. Okay, so let's try and draw this. We have a body of 10 kilograms, right? Sitting on an horizontal plane, and then the force is applied to it. The force is applied to it at an angle. The angle is 30 degrees. Okay, the force is applied to it at an angle of 30 degrees. Probably the force is trying to be is trying to pull it along this horizontal plane. Okay, and the magnitude of that force is 45 newtons. Okay, so the question says to find the distance covered in 15 seconds to the nearest meter. First of all, we need to calculate the acceleration. All right, and it's 30 degrees. Okay, so using our Newton's second law of motion, we know that the F equals what? Mass times acceleration. Now, the force we're going to be using, because the force is at an angle, which is 30 degrees, we're going to be using, and it's moving along the horizontal plane, so we're going to be using the horizontal component of the force. Remember the previous question number 32. This is an application of question number 32. Okay, so we only need the horizontal component of the force, which is just going to be what? F cos theta, okay, equals what? MA. If it were the vertical component, we need to have been F sine theta. And so F cos theta, we have the F is a 45. So we have 45 cos 30 equals what's the mass? The mass is 10. And acceleration, we do not know the acceleration. Let me get my calculator. Okay, so what's going to be F cos theta? That's going to be 45 cos theta. That's 45 cos 30. That's going to be 38.97. So that's going to be 38.971 equals 10A. So A is just going to be what? 38.971 divided by 10. That means take it for backward one times. You take it backwards one time. That's going to be 3.8971 meters per second squared. All right, that is the acceleration. But the question is to find the distance in 15 seconds. Now we have to apply our equations of motion. So we need the ones that have, let's write out the parameters. We have our A, which is already 3.8971 meter per second squared. We have, it says the body is initially at rest. That means the initial velocity has been given, which is U, which is what? 0. And then on a smooth horizontal plane, find the distance covered. So we are looking for distance, which is what we do not know. And 15 seconds is just the time. So the time is what? 15. Of course, what are we going to be using here? Which equation of motion has all of these parameters? I think it's going to be S equals UT plus half AT squared. So that means S equals what? U is 0 times 15. So 0 times 15 is 0 plus AT. A is 3.871 times the T, 15. T squared is going to be 225 all over 2. So that's going to be our distance after 15 seconds. That's going to be 3.871 times 225 divided by 2. So the answer is 435.48. But it said he wants it to the nearest meter. That's the nearest whole number. That's going to be 435 meters. So yeah, the distance covered in 15 seconds, is 435 after a force of 45 newtons that has been applied, on the body along the smooth horizontal plane. So the answer is 435. So see you in the next question.